Ever wonder what really happens when you click play on a video? It might seem simple, but there's a fascinating process happening behind the scenes every single time you watch something online. Instantly, a high-def cat video appears on your screen, ready to entertain you. But it's not magic, it's a complex dance of technology and action, working seamlessly to bring you content from anywhere in the world. That single click sends a digital request racing across the globe, searching for the exact computer or server that stores your chosen video. This happens in just milliseconds thanks to the speed of modern networks. The internet is a vast, physical network made up of millions of computers, cables, and routers. All these parts work together, forming a massive web that delivers information at lightning speed no matter where you are. Think of it as a global team project where every device, big or small, has a specific job to do. Each one helps move your video from its source to your screen. To make sense of this invisible journey, let's use a simple analogy: the postal system. It's a helpful way to picture how data travels. When you send a letter, it travels through trucks, sorting centers, and delivery people before finally reaching its destination. Each step is crucial for the letter to arrive safely. The internet works in a similar way, but instead of letters, it's data packets zipping through cables and routers, millions of times faster than any postal service could ever be. So, let's explore this digital postal service together and see exactly how your video gets delivered from a distant server all the way to your device. Ready? Let's dive in and uncover the journey. The internet is like a worldwide road system for information, connecting billions of people and devices across the planet. Imagine a vast, invisible network that stretches over continents and under oceans, linking every corner of the globe. This network is built from countless wires, fiber optic cables, and wireless signals, all working together to move data at lightning speed. These cables and signals connect cities, countries, and even your own home, forming the backbone of everything we do online, from streaming videos to sending messages. Your home network is like the neighborhood streets, guiding information to and from your devices, making sure your data finds its way. Meanwhile, internet service providers, or ISPs, manage the highways, bigger, faster routes that connect neighborhoods to the wider world, ensuring smooth and efficient data flow. No single person or company owns the entire internet. It's a decentralized network run by thousands of organizations, all cooperating and following shared rules called protocols to keep everything running smoothly. Thanks to this global cooperation, your request, whether it's a search or a video call, can travel from Ohio to Tokyo in the blink of an eye. The cables and networks act as the roads and highways for your digital mail, carrying your information safely and quickly to its destination. Every email, photo, or video you send or receive travels across this globe-spanning infrastructure, passing through many hands along the way. The goal? To get information from point A to point B as quickly and reliably as possible, no matter the distance. And all this data doesn't travel as one big chunk. It's split into tiny pieces called packets, each taking its own path to the destination. Let's take a closer look at how this incredible system works, and see what happens to your data as it journeys across the world. When you send or receive something online, whether it's an email, a photo, or a video call, your device doesn't send the whole file in one big chunk. Instead, it breaks the data into thousands of tiny data packets, which you can think of as digital envelopes. Each packet is a small, manageable piece of the original file, making it easier to send information quickly and efficiently across the internet. Each packet contains not just a piece of your file, but also important information, like a label with the destination and return address, and a sequence number. This label acts like a mailing address, telling the network exactly where the packet needs to go, and how to put everything back together at the end. Why use packets? Well, if one packet gets lost or delayed along the way, only that small piece needs to be resent, not the entire file. This makes the system much faster and more resilient, since it can recover from errors without starting over. What's even more impressive is that packets don't have to stick together. They can travel along different routes through the network, taking detours to avoid traffic jams or busy connections. This flexibility helps keep your data moving smoothly, even when parts of the internet are congested. When all the packets finally arrive at your device, your computer reassembles them in the correct order, like piecing together a digital puzzle. Even if they arrive out of sequence, the sequence numbers help put everything back together perfectly. Amazingly, this entire process happens in just milliseconds. It's so fast and seamless that you never even notice it's happening behind the scenes. This clever system of breaking data into packets and sending them independently is what keeps the internet running smoothly and reliably, no matter how much information is being shared. But how does your device know where to send each packet? That's where addresses come in. Unique identifiers that guide every packet to its destination. It all comes down to addresses. Let's break that down and see how your data finds its way across the digital world. Every device online has a unique IP address, a string of numbers like a digital street address. Your computer needs the exact IP address to send or receive data, just like mail needs a house number. But remembering numbers is tough, so we use names like Google.com. The Domain Name System, or DNS, is the internet's phone book. When you type a website name, your computer asks a DNS server for the matching IP address. The DNS server looks it up and sends back the number your device needs. This translation lets humans use easy names, while computers use precise addresses. Without DNS, the internet would be chaos. Now, let's see how all these steps come together when you load a website. Here's the journey, step by step. Here's what happens when you visit a website. You type the address and hit enter. Your browser wants to find that site. First, it asks a DNS server for the site's IP address. With the address in hand, your browser sends a request packet across the internet to the website's server. The server receives your request, gathers the files, HTML, CSS, JavaScript, and breaks them into packets. These packets travel back to your computer where your browser reassembles them. The browser builds the page, HTML for structure, CSS for style, JavaScript for interactivity. In seconds, the complete website appears on your screen. All of this happens in the blink of an eye. Let's tie it all together with our post office analogy. You want a model airplane from a catalog. You know the name, not the address. Your browser is you, the catalog is the domain name, and the DNS is the phone book that finds the address. Your order is broken into small envelopes, data packets, each labeled with the server's address and your return address. Routers act as sorting centers, sending packets along the fastest routes. The server receives your packets, builds your order, and sends it back in pieces. Your browser reassembles the pieces and you get your model airplane, a fully loaded website. That's how the internet delivers information, fast and reliably. Now you know the secret behind every click. Ready to learn how websites are built? Stay tuned.